Am I audible to everyone? All right. Chalo, then let's start our session for today. Hello, Anish. Hello, Kritika. All right. The first question is displayed on your screen. In the circuit shown below, the power developed in the 6 ohm resistor is 6 watt. All right. Now the power in watts developed in the 4 ohms resistor is. You have 2 minutes. Yes, Kritika, right answer. Anyone else? Don't necessarily wrong answer. Hello, Yash. This is the first question for today. You can take 1 minute to solve this question. Anyone else with the answer? Or shall I proceed with the solution? Alright, guys, let's proceed then. See, in the question, it is talking about the power of a developed in a resistor. Alright, so what is the formula for power? It is V into I. Alright, now we have the potential which is common for both of the resistors. So we can also write this as we can substitute I by V by R, so it will become V square by R. Alright, now we have power for developed in the 6 ohms, which is 6 watts. So 6 equals to V square by 6. That gives us V square equals to 36. This V square can be used to calculate the power for 4 ohms, that is P equals to V square by R, that is 36 upon 4, which gives us the answer as 9 watts. Alright, so B is the answer. Clear to everyone? Alright, आगे बढ़े. Alright, okay. Next question. This is a direct question. The value of internal resistance of an ideal cell is 0.51 or infinity. Yes, Kritika, right answer. Yes, right answer. Yes, Nishya, right answer. Alright. The value of internal resistance of an ideal cell is always 0, because when the internal resistance is 0, then it offers, yes, Anish, right answer. Then it does not create any hindrances in the current. Yes, we are doing current electricity. Alright, let's move ahead. If resistance of each wire in the network shown is R, the equivalent resistance between A and C is equal to. Alright, this is a network and the resistance of each wire, that is from A to C, that is this wire, this can be taken as a resistance from A to E, E to C, and in all of the partitions there is a resistance of value R. Alright, like this and this, and similarly here. Alright, you have 2 minutes. Yes, right answer. Yes, Kritika, right answer. Yes, Nishya, right answer. All right, shall we proceed with the solution? Okay. See, at this point C, thus this circuit is short, so no current will flow over here. So this circuit can just be simplified as this. All right. Now we want to find the resistance between A and C. So this and this get in series. So this is 2R, and here is R between A and C. So 1 by 2R plus 1 by R gives me 3 by 2R, and inverting it we get 2R by 3. That is the option C. Alright, आगे सबको समझ में? I think Anish did not answer this question. Anish आ गया था समझ में? Alright, no problem. I hope you understood the solution. Alright, no problem. Alright guys, let's move on to the next one. In the figure given below, find the equivalent resistance between A and B. This is a slightly complex structure given over here, and we have 2 points A and B. We have to find the potential, sorry, the equivalent resistance between A and B. क्वेश्चन सबको आ गया समझ में? किसी को क्वेश्चन समझने में प्रॉब्लम हो तो पूछ लेना. Yes, Nischay, right answer. Yes, yes, right answer. Shall I proceed with the solution, or do you need more time? All right. See, first of all, we can clearly see some of the resistors that are in series, that is, especially these and these. So we can simply make this as this is 2, this is 4, this is 3, this is 6. Alright, and this is connected over here. Alright, now what we can do, now we can name the points at the same potential, like this is B, and this is also B. And there is one separate point over here. Let us name this as C. Now we have 3 points at separate potentials. So let us try to simplify this. We have one, this is also A. We have one resistor. Anish, I think you missed one question. You can ask later on. From A to B, we have a 2 ohm resistor. From A to C, we have a 4. From B to C, we have a 3. Alright. And again from a B to C, we have a 6. Now we can easily see these two are in parallel. So this becomes 1 by 6 plus 2 by 6, that is 3 by 6. So this equivalent becomes 2. And then this and this are in series. So this becomes 6. So we can simplify this as 2 and 6. And then 1 by 2 plus 1 by 6 becomes 4 by 6, and inverting it we get 3 by 2 as the answer. So C is the answer. आगे समझ में? Alright, shall we move ahead? Alright. In the given circuit, each resistor has resistance R. The equivalent resistance between A and B is. You have 2 minutes. Yes, Kritika, right answer. Anyone else? Shall I proceed with the solution? Yes, Nishchay, Anish. Alright. See, this potential is B, so any part of the circuit that is connected to B without the interference of any device is also at the potential B. Alright, so this is B, this is also B, this is also B, and this is also B. So we can clearly see that a single potential A is connected to only B from four different resistors. So this can simply be said that four resistors are connected in parallel. Alright, all of the values of resistances are R, and these are four, so the resultant of the circuit has R by 4 resistance. Any doubt to anyone?
How is the middle point same as B?
The middle point is not same as B. The middle point is at A over here.
Oh, okay, okay.
Alright, anyone else? Shall we move ahead? Alright, next question. A heater coil is cut into two equal parts. A heater coil is nothing but a resistance, and only one part is now used in the heater. The heat generated will now be, and you have to assume the potential difference is same in both cases. किसी को क्वेश्चन समझ में ना आए तो पूछ लेना. Yes, Kritika, right answer. Yes, right answer. Yes, Nishchay, right answer. Alright, shall we proceed with the solution? Alright. The heat generated, that is power into time. So we can assume time to be same in both the cases. So we'll just take power. Now we know power and having the same potential difference. So we can write power in the terms of potential and the resistance, that is V square by R. So we know that power is inversely proportional to resistance when the potential difference applied is constant. So when the heater coil is cut into two equal parts and only one part is used, then the R has become half, the resistance has been halved. Now power is inversely proportional, so power will get doubled. Alright, so C is the right answer. बढ़े आगे. Okay. Alright. In the circuit shown below, the potential difference between the points C and B will be, that is this point and this point. You have 2 minutes. No, loop law is not required over here. Try to find out how much current is going in that branch. Yes, Nishya, right answer. Shall we proceed with the solution? Let me know if you need more time. Alright. We want to find the potential difference between C and B. So first let's try to find out how much current is actually flowing into the circuit. Alright, and to find that we have to find out the equivalent resistance. So I can see these both are in series. So I can simply write this as 10, and A point does not matter over here, and all these are in series again. So this can be written as 15. Here is 5, and then the potential is applied like this. Alright, now this point is also C, and suppose we name this point as, alright, this has a name D. So we can make a simpler circuit that is having C, B, and D, and we have one resistance between C and B, that is 10, one resistance between B and D, that is 5, and one resistance between C and D, that is 15. And the potential is applied between C and B. So we can say something like this. Alright, and what's the value? It is 2 volts. Now we can see the D point does not matter over here. These both are in series. So we get this becomes 20, this becomes 10.
So,
Yes.
isn't the potential applied between C and D?
Oh yeah, I'm sorry. Just a second. There is 5 between B and D and 15 over here. And this is between C and D with 2 volts. Alright, now we can see 10 and 5 are in series. So it becomes 15, and here we have 15 with 2 volts over here. This becomes 7.5 and V equals to 2. So we have V equals to IR, that gives us I equals to V upon R. Alright, so 2 upon 7.5 is the total current flowing into the circuit. 2 upon 7.5, we'll leave it just like that for sake of convenience. And we know that uh, the resistance in both of the branches is same, so it gets divided equally. Alright, so in first branch we are having 1 upon 7.5 and in another one we are having 1 upon 7.5. Now we wanted to find the potential difference between C and B. We have the current, we have the resistance in that branch. So we can find out V equals to IR. That gives us 1 upon 7.5 into 10. That is 10 upon 7.5. And if you simplify this, you will get 4 by 3. Right, so B is the right answer. आगे सबको समझ में? See, basically what you had to do in this question is you just had to find the total current flowing into the circuit and total current flowing into the particular branch, and just multiply it by the and just use the formula V equals to IR for the resistance across which you want to find the potential difference. Alright, shall we move ahead? आगे बढ़े? Alright, okay. In the balanced Wheatstone bridge circuit as shown in the figure, when the key is pressed, अभी ये key open है, जब इसको बंद करेंगे, what will be the change in the reading of the galvanometer? मतलब अभी open position में कुछ reading है इसमें, and जब इसको close करेंगे तो इसमें क्या change आएगा? This galvanometer is having its internal resistance as R. Yes, Kritika, right answer. Yes, Nishya, right answer. Anyone else? Yes, right answer. Alright, let's proceed with the solution. As we know that the Wheatstone bridge over here is balanced, therefore no current is flowing into this branch. Alright, I mean there is no potential difference. Even when the key is open, there is no potential difference between these points, suppose A and B. So even if you close the switch and the current can flow, but still it will not flow because there is no potential difference, so there will be no change in the current distribution of the circuit. So galvanometer will show no change. Alright, let's move ahead. The resistance across AB is. No, it's a wrong answer. Anyone else? Shall I proceed with the solution? Alright. Guys, this was an easy question. There was nothing much to do over here. We wanted to find resistance across A and B. So the points C and D do not have significance over here. Anish, you can ask the mentors for that. Alright, so this resistance can be seen as series. So this will become like this with 2R. Now this resistor are in parallel. So we can say 1 by 2R plus 1 by R, that is 1 plus 2, that is 3 upon 2R, and inverting it we get 2R by 3. And now we have from A to C there is R, and from C to B we have 2R by 3, and here we have R. Now these both are in series, by which we get 5R by 3, And now 5R by 3 and this R are in parallel, which gives us 3 by 5R plus 1 by R equals to 3 plus 5, that is 8. And inverting it, we get 5R by 8. This is the net resistance across AB, which is the option A.
So in this, we cannot remove the R connecting between C and B because it's a balanced Wheatstone bridge.
Um, no. Wheatstone bridge happens if the circuit is completed using this branch and this branch.
So
Alright?
not like assume or something.
No. If we had to find the resistance across A and D, then that would have been the case.
Okay.
Alright, any other doubt?
No. Thank you.
Anyone else? आ गया सबको समझ में? Alright, let's just take the last question for today. In the given circuit, it is observed that the current I is independent of the value of the resistance R6. This is R6. Then the resistance value must satisfy. Uh, Sorry, there's a misprint in the question. This one is R2. Yes, Kritika, right answer. Yes, right answer. Anyone else? Shall we proceed with the solution? Alright. See, the current I is said to be independent of the value of the resistance R6. That means no current is flowing in this branch. So what does this remind us of? This reminds us of Wheatstone bridge. Right. We have four resistance over here. We have one resistance in the between. So obviously this is a Wheatstone bridge structure. and which satisfies the Wheatstone condition, which is R1 by R2 equals to R3 by R4. Alright, and if you rearrange this, we get R1 R4 equals to R2 R3, which is the option C. Alright, आ गया समझ में सबको? Anyone having any doubts? Alright then guys, that's all for today. Thank you for joining. Alright.